you everyone for joining today, and feel free to use the chat function and let us know where you're joining in from. I know this is tinyML SG, but we have sort of made sure it's a online webinar. So if you folks are joining in from somewhere else, feel free to throw that onto the chat. Let us know where you're joining in from. Let others also know where you're joining in from. So yeah, thank you so much again for joining. And we also have the function for Q&A. It's there present. I know pretty much all of us are used to Zoom right now, but just letting you know, there's a Q&A function. So you can ask us questions at any time. And I am looking at the bar as such. So I will stop and I will take the questions as well. And yeah, welcome again. And let me get started. So thank you to all the tinyML strategic partners for committing to take tinyML to the next level together. Yeah, we also have tinyML EMEA Innovation Forum 2022 happening. This event will be held in person in Cyprus on October 10 to 12, 2022. So do register. And this call for presentations is open until August 1st, 2022. And yeah, you could also reach out for sponsorships. And tinyML, as you know, tinyML Foundation conducts a lot of events, and we have the next Trailblazer series going on, so do register. And we also have we have a meetup group and also a tinyML community on LinkedIn, so make sure you follow for upcoming events. And do subscribe to the YouTube channel. So all the all the videos and online webinars like this actually get recorded and sent to YouTube. So make sure you subscribe so you know the latest videos coming in. And yeah, so let me go ahead. So hi, I'm Archana. I currently work as a data product manager with this nonprofit called Women Who Code. Previously, I worked as a data scientist as well as machine learning engineer. And yeah, I love to work with hardware and work in the field of tinyML. And I think you'll get to know more of me during these webinars as such. But apart from all of this, I love cycling around and sort of biking around this very tiny island here in Singapore. And so that the last picture is a picture of me is biking. And maybe a short trivia question. I don't know if you folks are out of Singapore, but this is like a special spot. So maybe if you can catch where it is, do put it up on the chat. And yeah, let me go ahead and give you a brief introduction into ScaleDown. So today's talk will be about ScaleDown, and we'll be talking about, the different sorts of frameworks that are there in tinyML. And we'll also be talking about how ScaleDown comes and helps to bridge this gap. And finally, how can you get involved? And that's the major question that we have since it's an open source initiative. So giving a brief introduction into why we started ScaleDown. So we realized doing tinyML is hard. So there's less educational resources available. I know there are a couple of courses that are out, but there's less education resources as such because this field just came up in the last few years. So people are still catching up and making sure there's resources available. There's a need for hardware for sure. So this field sort of sits in between both electronics and machine learning. You can almost imagine it to be a Venn diagram, right? It sits somewhere in between. And so what we realize is we need both hardware and we also need this sort of hardware and software ecosystem that coexist together. So it's almost fragmented, and that's why learning tinyML is hard. And ScaleDown aims to democratize this using tinyML education. How do we do that? So firstly, we make sure to provide open source educational materials. And by giving users access to free hardware via our library. So this library, you can consider it to be like a physical library, and we're making sure to give you more access to hardware. And we'll explain about it later. And also by abstracting away the hardware and software difficulties through our framework. And I also want to go ahead and introduce Soham. So Soham, I can't see your video, but if you're there, just make sure that you go ahead and say hi. So Soham is actually the person who's working on the framework end. So he'll also be talking about what we have done up till now and talking about the various frameworks available. And let me go ahead. So yeah, one more thing that sort of pushed us to doing ScaleDown is that last year we actually saw that, um, personally for me, we were trying to like, even like, I bet like other people can also relate here. We were trying to actually order in hardware. And what we realized was it was taking a long time to do so. And even for something as simple like an Arduino Nano, it took us like almost 3 months to get the hardware. So what we realized is that it couldn't only be happening to us. And we knew there were other phenomena which was affecting it. Like, for example, the current economic crisis or the war going on. So we thought all of that must have pushed it. So we went and checked on the stats. And this is like quite recent that we checked on it. And we realized, yes, there is a huge hardware accessibility problem. So last year we saw that the lead times for chip orders almost doubled to more than 20 weeks. Moreover, there was an estimated chips shortage of 10 million units last year, with a shortage of more than 2.6 million units in the last quarter alone. We put out numbers to make you realize that what happens with hardware accessibility is that since we work in a field like tinyML, which, as I said, at the core of it is the hardware sits at the core of it, unlike other machine learning domains, we realize, we are pushing more and more people outside this domain when we sort of, have less accessibility to hardware. And that is another reason why we started this, is that we realize if we have lesser people starting in this field because of hardware issues, we'll end up like not having more growth. So that is another reason why we started ScaleDown. So let me now talk about the various verticals available. So basically we have like two verticals, which is one is education and the other one is framework. So education involves like books, blogs, study group, research. Framework is basically optimization techniques, benchmarking, and tinyML ops. So tinyML ops is tiny machine learning operations. It's basically involving all the domains and making sure that we have a proper pipeline in place when we actually go and deploy models to the edge. And so on the top here, you can actually notice, I'm trying to see if I have a remote, but yeah, on the top here, you can actually notice a thing called hardware library. So the education is sort of like, it sort of goes into the framework via the hardware library. So this is where, the last slide I talked about also comes into play. So we talk about this physical hardware library that exists, which is essentially like, we have started it right now, wherein like we're giving away hardware that we have. And you can go ahead and access that to actually use the framework and deploy the models. And obviously it's open source, so you're free to use whatever you want, but we will try to make sure that, you can get started and you can start implementing your first tinyML projects via this, and you're not limited just because there's a hardware shortage. And then on the downside, you can see the framework also feeds into the education back again. So making sure there's a cycle and the community keeps going on. So this project is like, you can take this particular framework and build your machine learning projects and actually post about it, right? You talk about how you're doing this and you talk about it to the community. So it almost forms a cycle of its own. So that's our idea with ScaleDown. And you can use anything for this, right from, Hackster to going ahead and putting it on other different sites like Instructables and so on. But the idea is that if you are someone who's part of this and you're using the framework and the library, that you also give back to the community so that someone else learns from you. And for doing this, we are actually, as I said, there's various pillars to it. And one of it, as you know, is the framework. So the first one in the framework is optimization. And optimization techniques, we're using quantization, pruning, and knowledge distillation. And for frameworks, we are venturing into PyTorch, TensorFlow, and OpenVino. And we'll also give you a brief introduction between this. But another idea that we have with ScaleDown is that we don't want you to be limited by the hardware you got. Like, for example, if you know a certain framework, like let us suppose that you know TensorFlow Lite really well, but you got an Intel-based hardware and now you have to learn OpenVino. So we don't want you to be suddenly limited by, oh no, I have this huge learning curve of understanding OpenVino and then implementing it on the Intel device. Can I actually use a way in which I can quickly move from TensorFlow to OpenVino? So the diagram above is, that's what it signifies. we're trying to also build a framework which supports moving from one particular framework like PyTorch, TensorFlow, OpenMiner to another. And what do we want to achieve through this is, again, more accessibility and furthermore like democratization, right? So that we are not suddenly this fragmented system that we sit in, where we have to learn so many frameworks and have to know about so many devices reduces. So that's our basic idea with ScaleDown. And let me also talk about the education aspect. So education is our like first pillar that exists. There's a question already. I let Soham take this because he's going to talk about frameworks. So yeah, I'm just going to quickly wrap up on the education and hardware library. And so education, way that we mean to like talk about education is articles, talk about, go about and have a documentation in place. And I'll also walk you through the current website wherein like we have a documentation present. And then we are doing this study group. So this is like the first part of the study group with tinyML and tinyML Foundation. And we also have other parts coming up, and we'll also give you a brief towards the end. We also have research paper ideas. So I think like research sits at the core of any machine learning, problem or application, right? Like at the end of the day, you need research to fund it back as well. So I think one of the things we realize is that with the power of open source, we can also implement research papers. So I think that is another area we'll be focusing on, is just understanding tinyML research papers, reading it and implementing it. I want to stress on implementing it is because in the past we have read a lot of papers, but I also want to get my, go out there and actually start implementing it. And then we also have social media content and looking at conferences. So we have one course that is just like an learning tinyML that's getting released with LinkedIn Learning. So I'm really excited about that. It's actually going out today, but I'll go ahead and post it on various social media platforms. So do make sure that you follow it. And we're also going ahead and publishing books. So what we realize is that there are a lot of obviously books that are being released on tinyML, but we want to push more content out there. So we are writing a book with Manning Publications at the moment on tinyML Ops, which is the general like tiny machine learning operation system that exists, like the entire pipeline. And in terms of the hardware library, there's resources about how to start your own hardware library, the logistics involved, how you can get new hardware, and the integration of the framework and the support. And then I will let Soham talk about the frameworks.
Yeah, sure. Hi, hello everyone. Not sure why my video, I can't see it. I'm not sure if you can. But yeah, so the idea behind, okay. So the idea behind the framework is we want to support like new algorithms as they come out. And we also want to support those on all the new hardwares that come out. Because we see that, like there's like a new quantization technique or a new pruning technique that's released like every few months, right? Or sometimes every few weeks even. And there's really no way for you to actually try those out on different hardware to see how they actually perform in real life. So that's something we also want to try to support. And then we also want to support all the new frameworks that are present, and we want to kind of build like a unified wrapper around all of them so that you don't need to really learn different frameworks and you can test them out quickly and then iterate through them quickly. And yeah, so finally, we also want to like make it easier for you to deploy those models by helping you create like let's say deployment packages that you can push to different devices. So that will help, and it should all be kind of like automated, so so you don't really have to do much. And then before we deploy, we also want to benchmark the models and then find out like the performance you might get. And we also want to do AutoML, so that let's say you have like some data and you want to quickly train a few algorithms to see how well your model will perform on them. So you can use AutoML to do that. Yeah. So Archana, do you want to maybe talk about this?
Yeah, sure. Thanks for that, Soham. And I think you would come back again when we talk about the frameworks in general, and we have a question for that already. So yeah, so I mean, some of the optimizations we are looking at, and I just want to give a general introduction here. We'll also have like each of the study group going into each of the optimization techniques in detail and making sure that we are talking about them and also talking about the current research papers available and also implementing them. So yeah, so the first one that we will first one I'll talk about today is quantization. So quantization, as you know, like all our neural networks, probably you know this already, so this is like a quick primer or quick refresher. Neural networks as such use like 32-bit or 64-bit floating point values, and these require more memory to save and custom logic to execute efficiently. So we end up like converting the weights to int 8 or 8-bit. We can save memory and make sure the compute works in a faster manner. However, this leads to an loss in accuracy since we lose precision. So this field or this optimization where we actually end up converting neural networks from a higher bit to a lower bit is quantization. And another optimization framework is model pruning. So model pruning, as you know, when you hear the word pruning, you know, it means like you're cutting something off. So yeah, this over here, you cut off parts of a neural network. You can either cut off the weights or you can cut off the neurons. So executing prune networks efficiently is quite difficult. And so this sort of the thing that moves around this is called like model pruning, and we will also look into that. And finally, we also have knowledge distillation. So how does knowledge distillation really work? So it works by transferring knowledge that is learned by a large teacher model to a smaller student model. And since like the student model is easier to execute, it can be trained on, for example, unlabeled data. And a student model can often achieve similar or more accuracy than the teacher model. So these are like on high level the optimizations we'll be looking at. Now coming on to the framework side.
Yeah. So for frameworks, we are trying to at the moment support a few, but then there's also different types of frameworks, right? So there's frameworks that you can use to optimize models. So the most popular, which is like TensorFlow Lite, you can do like, let's say, quantization, pruning, and weight clustering. But not all frameworks are built equally, right? So you also have other frameworks like OpenVINO and PyTorch, but they can only do quantization. Also, the type of quantization they do is kind of different from, or like their implementation is different from, like, let's say, TensorFlow's implementation. So what we want to do is like create like one common API, and let's say you want to try out like OpenVINO's quantization. So you can like use the same API to quantize your OpenVINO model, or let's say you have like a TensorFlow Lite model, and you want to convert it to like a PyTorch model and then use PyTorch quantization. You can also do that. Moving ahead, there's also like a few other frameworks for edge computing. So there's different model representations. And this is also like a huge problem in edge computing because there's kind of like this disconnect between hardware and software. And only few hardware support like only some specific software frameworks. So for instance, like let's say TensorFlow Lite supports Raspberry Pis and Arduino devices. But then OpenVINO doesn't support, it just supports Intel devices and like neural compute stick. So that's kind of like a challenge, right? Because let's say you want to deploy a model trained in TensorFlow to a neural compute stick, you have to like follow these complicated steps to convert the model first. And that might lead to a lot of errors and lead to more challenges, especially for beginners, right? There is some work being done by ONNX to kind of consolidate all these different formats, and we also support that as well inside ScaleDown. And finally, there's also different frameworks for deploying models. TensorFlow Lite has like the TF Lite interpreter to deploy to Arduino devices. OpenVINO, you can use that to deploy to NCS and all. And there's also DeepStream and TensorRT, which are like optimized libraries for deploying to NVIDIA devices like Jetson. Yeah, thank you.
So we had a question. Do you want to just answer that?
Yeah, actually, I was like typing that answer, but maybe I'll just like say it. So the question is, like we have all these alternative engines like PyTorch, TensorFlow, and OpenVINO, and can they be consumed separately? The answer is like yes. So the idea for us is these different engines, they're kind of complicated, especially for beginners. And for people who and if you're someone who just wants to try something out quickly, see the result, see if it works or not, and then move on, you can't really do that, right? Because you need to learn all these APIs and all the different settings to actually get like the optimal performance. So the idea for us is that we want to create like a single API that will help you work with all the different engines. And you can also easily convert models from like one format to another, so that you can train using one framework, like the framework you're comfortable with, and then deploy using a different framework and to a different device that may not be even supported by the original framework.
I hope that answers the question. If it does not, feel free to ask us more. I think there's another question.
Yeah, so how steep would the learning curve be? So we're hoping it's not too steep. Archana, maybe you can show like the knowledge. Okay, maybe later on we can show like some code snippets for like, let's say, training a model using knowledge distillation. And yeah, just to show you like how easy it is.
Yeah.
And yeah, and then like when ScaleDown end users started to be charged, what is the business? Oh no, it's open source. So and like both of us have like full-time jobs, and yeah, ScaleDown is we're genuinely not trying to like monetize it. It's just something we feel like the community does not have, and yeah, we just wanted to build something for it to make it easier. It started out kind of as a project for me and Archana personally, because we wanted to build like projects, but we found ourselves like really limited because like limited in terms of time, right? Like there's so many frameworks, and it's really difficult to deploy to one model, and then if you want to deploy your model to a different device, right? It's like it takes like months of work to do that, and yeah, we just wanted to simplify it.
Yeah. And I think like when we talk about how you can get involved, we're also going to talk about how you can give back. I think one of the things that we strongly believe in is, since it's an open source project, we definitely want people to start contributing as well, and sort of like find out areas like where you think like this package can be better, and let us know. I don't like as like machine learning engineers and people who work with machine learning, often we obviously use a lot of open source packages. And if you go check out any well-known open source package, like even pandas or numpy, you will see it's heavily done by the community. It's at the end of the day, it's the community that helps to make sure it runs well. So I think like make sure that you can go ahead and let us know, like raise issues on GitHub, and also make sure that you contribute to the code. And I think Soham will be talking about that later on, how you can contribute and what's the current structure of the repository. But yeah, I think we don't have any business model, but what we have here is like something open source that we hope gets contributions. And yeah, and so this is a good like way to start about how to get involved. So how can you get involved? So there's various ways. So I hope you got you a little excited, if not too much interested, but we hope that we got you a bit excited about this. The first is how you can request for hardware, and then you can write like and write content and resources. This could be also like writing documentation or training resources for someone else to get started with this. Obviously, research is one of the things we definitely believe in, and we are trying to even work with professors to get more research in and understand if, oh, can we take ScaleDown and implement something that's coming up. And I will talk about our research paper ideas that we have as well. And then obviously it's building the package. I think that's at the core. So let me first talk about requests for hardware. So this is our current like ScaleDown website. I hope it's visible. It is, right?
Yeah.
Okay. So yeah, so the you can click on library and then go to hardware library. So so it talks about what is this hardware library and how does it work. So you can also check out the list of hardware and specs available. So if you click here, it takes you to all the hardware that we have present, like both microprocessors and microcontrollers and all their high level specs. Obviously, if you want to go check out their data sheets, just Google the name and you'll get it. And these are the hardwares we currently have available on the library. And then you can then move on to request for hardware. And we have this fun infographic on how you can request for hardware. Unfortunately, it's only for Singapore right now in terms of the hardware. The framework is available worldwide because it's like hosted on GitHub. But currently we are trying out this hardware library. Since it's been also a very new concept, we are trying it out on Singapore. And given how tiny our geographic is, we're hoping to sort of start to give more people hardware. And so how you could request for an hardware, there's an entire infographic on it. And you could also donate for hardware. So if you're based out of Singapore, and as you know, there's a huge hardware crisis sort of going on in the community, and you feel like there is like hardware that you can donate, so feel free to donate us the hardware. You can it'll really help us. And and then you can request for hardware here. There's like a Google form. I can also open this form, but it basically asks you what type of hardware do you want, like in case it's not available, the second choice, and so on. And and we also have an FAQ here in the introduction section, like how do I know which hardware do I want, how do I return my hardware, and how can I get more hardware, etc. So this is the first part, is like how you can request for hardware. And then there's also the part about how you can write content and resources. I think like a lot of us want to start writing and contributing. Like I think like personally for me, I feel very motivated when I write for something. And if you're someone like that and wants to write, we definitely want to give you the platform to do so. And we'll make sure to put up your blog on the website and also on GitHub so that folks can check it out. And so creating content, like how can you get started? You can get acclimated to our current like user guide and website development. Sorry. Okay. And then probably write a blog on tinyML. If you haven't like explored this topic before, you can write some introductory blogs. I know there's a lot of content out there, but any perspective is good, and anything that gets you started on this journey is good. And so, and then you can build a project and publish that as a blog, or even like write documentation or write like any training resources. And then also help us create study group content. So like, as I told you, this is like an ongoing study group that we're doing. We'll be talking about, for example, the next one that we're doing is on knowledge distillation. So we'll give you an introduction to knowledge distillation. We'll give you like, tell you about how other frameworks implement it. And then we will tell you how we are doing it via ScaleDown. So we'll try and give you like all the resources available. But if you feel like, oh, something else can be added, or I want to take up the next study group, reach out to us. Again, like this is a community effort and we want to involve as many people as possible. And you can also present at meetups. So as I said, one of it is here, but also like any other conferences. We presented at the last tinyML Foundation conference as well, a poster out there. But yeah, feel free to let us know, and we would love to like apply for conferences. And how can you get involved? We also have the research part of it, as I said. So research, we are like, thinking about research paper ideas. One of it is how can we quickly implement like research algorithms. So for example, almost 2 years ago, we had this algorithm called early exits that came up, and it was pretty interesting. But I know like early exits was basically a way in which you could, as the name suggests, you could quickly exit out of a neural network without basically going through the entire inference. So for example, let us say you trained a model that recognizes cats in an entire pre-trained model that was trained on animals, and let us say it quickly recognized cats in the first two layers itself, and now we want to get out of it. So that's actually early exits, and that was really interesting because it had like potential to be implemented for edge computing of a tinyML. So like something like that, we want to make sure that there is like some like if there's a research algorithm, can we try use ScaleDown, or can we try and make sure that we are taking such and implementing it quickly. And let me know, Soham, if I'm saying something wrong, or my technicality is wrong over there.
No, it's actually really great. Yeah, so the idea is basically if you exit out early without like, executing the whole network, then you save compute, you save memory, you save power and all of that. Yeah.
Yeah. And we can also, like, we are doing paper reading here, so we'll make sure we talk about the upcoming papers or papers in the field. So for example, Soham has this paper on knowledge distillation that he has been reading, and so something like that we would love to share it with the community. Then there are research papers. So some papers are tinyML ops with ScaleDown, optimization techniques, and so on. And apart from that, it's also about like building the package. I think that also sits at the core of what we do. So Som, do you want to talk about how they can contribute to the package as such?
Yeah, sure. So I think the first way is by writing code. Archana, maybe you can move to the next slide. Yeah, so the link to the GitHub repo is on the top left. It's really simple. So all you would have to do is create an issue, and then pick up or if there are any existing issues or action items, then you could pick that up. If you want to contribute something new, then that's when you would create an issue, right? And then so we've made the framework kind of very simple to contribute to on purpose, so that we get a lot of people helping out. So all you would have to do is kind of like go to a folder for the kind of algorithm that you want to implement, and then add your implementation in there. And we'll then help out creating, like, let's say, documentation and examples, and we'll also help in like integrating it with the rest of the framework. If you want to like go the extra mile, that'll be great. So you could add like tests for your algorithm, and you could also help make sure that your API supports different frameworks, so that way more people can also use it. And yeah, once you're done with all of that, all you would have to do is like just create a PR. But if you feel like contributing code is like a more challenging for you or something, you could always help out by creating more resources that's like non-code related. So like that would be like documentation and code examples and all. Archana, could you move to the next slide? So for that, yeah, there's like the blog that Archana showed sometime like ago. The how you can contribute to that is going to the repo link in the top left, and it's made using mkdocs, so you would just have to contribute by writing markdown code, which makes it really easy. And then just add either examples or maybe projects that you've built. You could also help us create user guides and like recipes for how to use each algorithm. Or you could just add like learning materials that about that helps explain all the different algorithms that are out there. Yeah, that's pretty much it. Archana, before we move ahead, maybe I'll just answer the question about like how steep the learning curve would be. And you said you're currently so it's a question by Anand, and he said like his engineers are currently using TF, and let's say like how difficult would it be to use ScaleDown? So if I can share my screen, Archana, if you could stop sharing for a
Yeah,
second.
I'll stop sharing.
Yeah, thank you. Um, so yeah, so here I have like a code example of knowledge distillation and weight quantization using ScaleDown. So the whole code is like less than 50 lines of code. But how you would do is like for knowledge distillation, you want to ideally like distill the knowledge from a teacher model to a student model. So what you would have to do is just load, sorry. So what you would have to do is load the model using ScaleDown, and then load your data. And once you've done that, you can set your like how you want to do knowledge distillation. So specify like your knowledge distillations, like the parameters and like the optimizer, the loss you want to use, as well as the models. And then finally, just like iterate through your data, and for each iteration, just call the train step here. So like kd.train step, and yeah, that's pretty much it. That will train your model. So this part is just like the knowledge distillation part. It's what, 4, 5, 6 lines of code, and and then like it doesn't matter, like here I've shown you using like TensorFlow, but you can do the same thing with PyTorch as well, like basically like the same lines of code. Of course you would have to change your optimizers and all, but the rest would remain the same. And then you after you're done training your model, you can get like a benchmark report as well that will tell you like how many flops of like how many flops you would need to execute a model, inference time, and so on. And then if you want to like take it a step further, you could also quantize your model. Sorry, you could also quantize your model, and then once it's quantized, you can like create a deployment package for your target device. Yeah, that's pretty much it.
Yeah, thanks a lot, Soham. I'll go ahead and share again. Before I do, we also have someone who has shared like um, I guess a paper. So thank you for doing that. I think it's about the introduction to tinyML ops and the entire ML orchestration loop, which is pretty amazing. I unfortunately don't have an IEEE account because I'm not, I don't have an academic account anymore, but I will go ahead and I will try and fetch the paper and I'll check it out. And if I don't have access to the chat, but if someone does, like Martia, you could also add it to the chat if possible, or maybe Rosina can. Can you please add that paper to the chat?
Yeah, I can do that.
Oh, okay. Yeah, I don't have access to the everyone part of the chat, so I thought it's
Okay,
best.
sure.
Yeah. Thank you. Thanks a lot. And thanks a lot, Martia. I hope I'm pronouncing your name right. Thank you. Okay, and moving ahead, so we also want to talk about the roadmap, what we have done so far and what we want to do ahead. It just keeps us grounded on what we are expecting, and make sure, like, since it's open source, we also want to keep some goals in mind and not get like deterred away. So yeah. And so one of it is so in Q2 we were looking for the initial path, so we made sure there's ScaleDown support for knowledge distillation and there's support for TF Lite and PyTorch. For Q3 this year, we're looking to start the hardware library, and we're also going to do a study group on that, like how you can choose your hardware and also like how you can apply for it. And then publish like one research paper. Like we just want to start looking at research paper ideas and try at least writing one. I know it's like a little far-fetched to try and publish it so soon, but we just want to start writing. So if you're interested, please do let us know. We would love to collaborate. Again, like this is something we're not doing behind closed doors. We want to make sure there's as much involvement as possible. And the next thing that Soham is looking at from the framework perspective is look at quantization and pruning. And we'll also cover like specific study groups for that, like talk about quantization, talk about pruning, and then support OpenWino and ONNX. And for Q4, we're looking at support for the entire like tinyML ops. And one of the things that we are particularly looking at is security aspect, which I think a lot of tinyML ops system need, because you're basically taking the model and deploying it somewhere away from the source. So we're going to look into that and hopefully complete like one cycle of hardware library where at least a few people have used the hardware and given it back to us. So that's the idea that we have. And we'll try to keep up the pace as much as possible. Maybe like down the line, things might change. But these are like the general goals we have. And yeah, join us, like these are the areas we have, but yeah, join our Slack link. We'll try and post regularly and talk about some of the upcoming papers and, talk about the upcoming contributions that we did and upcoming updates from us. And it's like, we just put up these memes here, but the idea generally is that this is like a open source, it's open source initiative. So we realize like it's going to be it's going to be something that is going to take time, but we also want to make sure that there's something like that out there in the community, especially for tinyML. And I realized like a lot of tinyML is driven by these companies. Like, for example, you have these large players, but you also have mostly companies driving it in. But we want to make sure that there's something out there for the community so that they can get started. They can, start implementing it quickly without getting, overwhelmed with all the resources available. So yeah, that's the basic idea. And can someone just drop in the Slack link? Soham, can you drop
I just did that.
Okay. So we're coming towards the end a bit, but I just want to quickly talk about what's next. So this study group was just the introduction to ScaleDown, but the next one we're looking at optimization techniques, knowledge distillation, and the next one would be knowledge distillation paper implementation. And after that, we'll be looking into how to apply for your hardware, like sort of giving you a welcome into the hardware library. And you can check out the link. So this meetup.com, that's where we host like all our events. So Soham, if you can also drop the link of meetup.com onto the chat so people can just, you can go ahead and become a member. And Rosina sends out these wonderful emails. So if you're part of the tinyML Foundation, you'll also get like a newsletter which will announce the event. A huge shout out to Rosina for that. And yeah, and okay, Som, do you want to talk about what you're going to do in the next 2 sessions, especially on the research paper side? Just give them like a overview on what we might do.
Yeah, sure. So there's this model optimization algorithm called knowledge distillation. And what we wanted to do was kind of like introduce the algorithm and then also show you how you can implement it using ScaleDown. And since the idea behind ScaleDown is also to allow not only like beginners, but also to make it generic enough that even researchers can use it. So we'll show you like how you can implement like a research paper that uses knowledge distillation using ScaleDown. So yeah, that if that's something that interests you, please do register for that event.
Yeah. Do you have the name of the research paper? Can we drop that, or do we?
I don't at the moment. Let me just find that.
Sure. Oh yeah, please do take your time. So until like Soham finds the next research paper we are looking into, you can like let us know any questions that you might have.
Paper is about like some good practices for making sure that knowledge distillation works. well when you're trying to train a teacher, a student model using a teacher. Yeah, that's what this is about.
Okay.
Yeah.
Yeah, and thank you once again, everyone, for joining in. I know it was like almost 45 minutes, so I know it's very hard to take out that time on a Thursday morning or an evening. So I really want to thank everyone present here for taking out that time. And yeah, thank you to all the tinyML strategic partners. So our executive partners are Arm AI, Edge Impulse, Qualcomm AI Research, Sentinent. Our platinum strategic partners are Deeplight, Kilka Tech, Reality AI, Renesas, and Sony Semiconductor Solution Incorporation. Gold strategic partners are Analog Devices, Fota Hub, Fota Hub, Latent AI, NXP, and Seed Studio, and also SensiML, STM, Synaptics, SynSense, and these are our silver strategic partners. And so thank you everyone. And again, like in case like you want us to stop the recording, you can still like ask us questions and feel free to reach out to us via Slack. And yeah, we hope to see you in our next study group. And again, thank you so much for taking out your time today.